Welcome to Mission Control. In this explainer, we are completely transforming how you approach your Cambridge AS and A-level mathematics syllabus. We are treating your exam paper not just as a test, but as a highly complex flight system that demands absolute precision, perfect telemetry, and flawless execution. Today, our primary mission objective on the central console is Syllabus Section 4.3, Linear Momentum. The payload? That famous equation, P equals mv. We aren't just going to look at the numbers today. We are going straight into the examiner's playbook to decode the exact system they use to grade your papers. To demonstrate this, I want you to imagine two pilots in our simulation today. We have pilot Alex, who has a habit of overcomplicating every single data calculation, burning way too much crucial time and mental fuel. And then we have pilot Sam, who tends to completely ignore structural boundary constraints, risking a total systemic breakdown. Our job as flight directors is to make sure your trajectory doesn't fail like theirs often does.
It is the ultimate high-stakes question, isn't it? What actually separates a candidate stuck in a lower orbit at a B from one who achieves that highly coveted A-star altitude? You can memorize every single formula in your flight manual. You can spend hours crunching numbers. But based on the telemetry we pull directly from principal examiners' reports, the answer almost always comes down to your mastery of one fundamental concept: linear momentum. It is the absolute litmus test for whether you are just pushing buttons in the cockpit or if you are truly thinking like a master systems engineer. Pilot Alex often gets stuck at a B because he calculates data that the question didn't even ask for, burning through his exam time. Pilot Sam gets a B because he rushes the final output, completely ignoring the parameters the examiner set. We need to clear those errors.
Here is the flight plan for today's mission. 1. Core principles. 2. The procedural framework. 3. Critical analysis. And 4. Examiner traps. Let's initiate the sequence.
Entering Phase 1, the core principles of momentum.
Before we even think about engaging the thrusters and plugging numbers into an equation, we have to establish a rock-solid logical foundation. The examiner sitting at Cambridge Mission Control can tell immediately if you are just guessing your way through the atmosphere or if you genuinely understand the physics and mathematics at play. Linear momentum isn't just mass times velocity. Straight from the Cambridge framework, it requires a connected, conceptual understanding that can be seamlessly transferred to unfamiliar contexts. You see, the command keywords in your exam, words like calculate, determine, or show that, these are your system parameters. Top-tier candidates don't just blindly recite P equals mv. They know exactly how to dynamically adapt that formula when the exam throws a completely unfamiliar, weirdly worded atmospheric anomaly at them. We are mapping out an answer framework that anticipates turbulence.
To test your readiness, the exam targets 3 distinct cognitive domains, which you can think of as your 3 primary navigation systems. They are assessing your knowledge and understanding, your application of the principles, and your critical analysis. Notice that raw knowledge, just knowing the formula, is only one slice of the pie. The exam is rigorously engineered to test far more than rote memory. Pilot Alex, for instance, overthinks the application phase, running endless calculations and burning his fuel. Pilot Sam, on the other hand, relies entirely on knowledge and completely neglects the analysis system, leading to a shallow answer. You have to balance all 3 systems to clear orbit. This brilliantly illustrates the exact mindset shift you need to make to maintain a stable trajectory. On the left, we see Pilot Sam's fatal error, superficial breadth, rushing to a final answer, skipping crucial procedural steps, and just trying to find a number to write down so we can move on. It's a rush launch. But on the right, we have the A-star trajectory, analytical depth. This relies on logical, structured reasoning. The Cambridge Assessment Framework explicitly prioritizes this depth. If you just rush to the final number without showing the examiner the structured reasoning of your flight path, you are leaving massive method marks on the table. Initiating Phase 2, the procedural framework.
Flight control, pause the simulation for just a second. Before we fire the secondary boosters to secure maximum method marks on this paper, you need to optimize your flight path. I need you to subscribe to Ace the Exams at Ace the Exams right now and turn on all notifications so you never miss a mission update. Okay, resuming the simulation. In Cambridge Mathematics, the journey you take secures your method marks. Systematic processing for momentum follows this exact 5-step propulsion sequence. Step 1. Identify your key elements. Lock your targets. What mass and velocity data do you actually have? Step 2. Apply the relevant principles. Prime your systems. Step 3, and this is the main booster ignition. Execute analysis with crystal clear working. Step 4. Verify your results. Check your telemetry. Step 5. Present it in the appropriate format. Listen to me carefully. If you skip step 3 and don't show clear working, the examiner cannot track your flight path and will not award you method marks, even if your final destination is miraculously correct.
But here is the catch. Before you can even begin those 5 steps, you have to successfully navigate the raw data you're given. Think of this as reading your sensor readouts. Data interpretation skills are your radar. You absolutely must be able to extract the correct variables from dense text blocks and complex tables. You have to interpret the physical relationships happening in the scenario and draw evidence-based conclusions. If your inputs are wrong because you misread the table, your perfectly executed 5-step propulsion sequence will send you flying in the completely wrong direction, resulting in 0 marks. Accuracy at the data extraction phase is everything.
Moving into Phase 3, critical analysis and evaluative thinking.
Alert on the console. Our pilots have hit a critical roadblock mid-paragraph. They're trying to secure the absolute highest marks by evaluating a mathematical system, but their evidence links are completely failing. I am overwriting the console right now. We need to inject a structural template to save his trajectory. Whenever you are asked to evaluate, you use the PEAL template: point, evidence, evaluation link. Evaluative thinking means questioning assumptions, considering different perspectives, and justifying decisions with hard evidence from your calculations. The syllabus explicitly states that higher-order assessment requires evaluating alternatives, comparing approaches, and making justified recommendations. It's about identifying limitations in your data. By injecting the PL framework, you structure your argument perfectly, linking your mathematical point all the way back to the core question, stabilizing your grade trajectory.
Final phase, avoiding common examiner traps. The debris field.
Initiating Interactive Viewer Radar Challenge. I want you to engage with the simulation right now. Imagine a 60-second visual countdown clock on your internal HUD. We are scanning a highly complex source graph, looking for hidden variables and navigating the debris field of examiner traps pulled straight from the principal reports. Simulation 1. Locating the core variable. Trap number 1 is using the wrong approach for the specific context. You can't just blindly fire a generic formula. It has to fit the scenario in front of you. Simulation 2. Debris detection. Your mission is to spot where the candidate falls below compliance standards. Trap number 2 is forgetting to check format and presentation. It is heartbreaking how easily a brilliant mind loses marks simply because they didn't present their final answer in the required format. And trap 3. Answers lacking contextual specificity. Vague answers are space debris. They get 0 marks.
Warning lights are flashing on the dashboard. I want you to read this critical examiner alert very carefully, straight from the source. Candidates consistently confuse key terminology. Always define terms before using them in extended responses. This is a non-negotiable flight parameter. If you are launching into a complex extended response about linear momentum, you must start by defining exactly what you mean. It proves to the examiner immediately that your foundational avionics are online and that you have that deep conceptual knowledge we mapped out earlier.
To help you execute a perfect full-mark touchdown sequence on exam day, I am uploading a quick memory hack to your systems. MVP. Yes, technically in the world of physics, it stands for mass times velocity equals momentum, but for your exam strategy, I want you to remember it as master the vocabulary and process. Master the vocabulary, master the process. If you have your terminology clearly defined and your 5-step procedural sequence fully mapped out, you are going to be the absolute MVP of this exam paper. Touchdown sequence initiated.
Simulation complete. Both pilots have successfully touched down with full marks. Now, here is your pre-flight question scan checklist. First, make sure you hit subscribe so you don't miss our future training simulations. Second, get your hands on some past paper questions and start running the drills. And third, don't just solve them. Apply this exact flight system. Practice the 5-step framework, practice defining your terms, and practice showing that analytical depth. Before you go, drop a comment below sharing your specific subject and tier so we can customize future simulations for you. Make sure you subscribe to Ace the Exams at Ace the Exams and enable that notification bell.
I want to leave you with this final provocative thought to carry into your next study session. When you sit down at your desk, fire up a past paper, and stare at that central console, ask yourself, are you just blindly calculating equations, burning fuel and hoping you land on the right number? Or are you actively proving your analytical depth step by step to the examiner? Shift your mindset from a passenger to a flight director and watch your grades completely transform. Thanks for joining me in Mission Control for this explainer, and I'll see you in the next simulation.